Hi everyone, so today we're going to go ahead and do a review on functions. So for this question, we're going to use the graph to the right. The first thing we're going to do is find the domain. So domain is all possible x's. So we're looking from the left to the right. So we have the left side of my graph, we're pointing towards negative infinity, and the very rightmost of our graph we're pointing towards positive infinity. And right here at 4 you do have an open circle as well as a closed circle, but that means that that point is going to be included. So we're going to have all real numbers for our domain. Now we're going to look at range, and range is the y value. So for range, you're looking from the bottom to the top. So we're looking at the bottom, which points down towards negative y values or negative infinity, going all the way to 4. And it's going to be a bracket because it's a closed circle. There is, again, some values that we're missing here. So we're going to use our union or. And our next y value that we hit is sort of a constant y value, and that's just going to be 6. And those are all included. Okay, so when we ask you to look at symmetry, we're asking you to look at functions that are symmetrical with respect to the y-axis or the origin, and those were going to be our even or odd functions. So in this case, this symmetry is neither, because it's not symmetrical around the origin or the y-axis. Next, we're going to ask you to describe the intervals of the x values on which the y values are either decreasing, increasing, or are constant. So what we're really asking you is, like, what's the x when the y is doing this, like when the y is increasing, when the y is decreasing, or when the y is constant. And we write these in interval notation, and you're not including your endpoint, so you will have parentheses on these intervals. So where are the y values increasing? So my y values are going to start here below, and then they go up and they go up, and they kind of hit a certain point. So that interval, so the x's are negative infinity going all the way to the x value of 4. And again, make sure you're putting parentheses around that. We do not have any intervals in which the y's are decreasing, so we're going to write none. We do have an interval in which the y value is constant. So that's this interval right here. So those x's are 4 all the way to infinity. Okay, next we ask you about what type of discontinuity is at x is 4. So right here, x is 4. So what's going on right there? That is a jump discontinuity. The last thing we're going to ask you is about end behavior. So as x approaches negative infinity, that's on the left side of my graph, my function is what? Right? So what are my y values? And then as my x approaches positive infinity, which is I'm looking on the right side of my graph, my f of x is what? Okay, so we're looking the left side of my graph, right? So we're looking over here. My function points down towards negative y values or negative infinity. And on the right side of my graph, my function is approaching what? That's actually a y value of 6. Okay, we've got another example for you here. Let's look at the domain. So again, domain is your x's. So we are starting here at negative infinity, going all the way and approaching the x value of 0, not crossing it. So we're going to put a parenthesis. It gets very, very close. We're going to put a u or an or. And our next sort of continuation is at 0, going all the way towards positive infinity. Our range is our y value. So again, we're starting from the bottom. We are looking at negative infinity, going all the way, sort of approaching 0, not touching 0, not passing 0. And then we're going to put an or, and then again, we're sort of continuing on after that value of 0 and pointing up towards positive infinity. When we look at our symmetry, again, we are looking at even, odd, or neither. And now this one is actually going to be odd. It is symmetrical around your origin. So with that case, you're sort of thinking about that your graph does sort of change those values, right? So if I have this point right here, I sort of flip my graph just on the opposite side, sort of diagonally. So my x's and my y values actually change both in an odd function. Again, we're looking at what are my x values when my y's are either increasing, decreasing, or constant. So my y values are not actually increasing at any points. So we're going to say that that's none. My y values are decreasing. So my y values kind of start at a little high point and they do go down. So those x values that I have there in that interval is negative infinity, right? And then x value here is 0. And our second interval where my y's are decreasing, they're kind of starting here, going down, approaching that value, got 0. And then the other x value is positive infinity. And then you look at constant. There's no values here where our y's are constant, so we're going to write none. Okay, what kind of discontinuity is happening at x is equal to 0? So this is actually an infinite discontinuity, so that's when you're thinking about when you've got those asymptotes, or there's like this imaginary line here that both sort of curves or branches of your graph are crossing, but they don't actually touch. And we look at end behavior as well. We're going to look again, my function, when my x is approaching negative infinity, my function approaches at value of 0. And then as x approaches positive infinity towards the right side of my graph, my function is approaching 0. So in number 3, we're going to find f of g of x. So we are doing a composition, and then we are going to state the domain. So what we're doing is we're taking our g function and we are substituting in for our f function. So our f is 3x squared. In this place, we are going to put our g function, which is 2x minus 1. So you've got 3 and then 2x minus 1, and that is squared. So when you look at that quantity that's squared, right, we are technically multiplying this 2x minus 1, 2x minus 1. So again, you can do your box, you can do FOIL, whichever way you're more comfortable with. However, you cannot just distribute the exponent in. We cannot do that. So when we multiply, we're going to get 4x squared minus 2x plus 1. So when we simplify, we're going to get 4x squared minus 4x plus 1. And then you're still going to multiply with that 3 that's in the front. So here we can distribute that 3 in. So that's 12x squared minus 12x plus 3. So whenever we look at a composition with domain, we're thinking about our inside function as well as our composed function. Because our inside function, which was our g of x, that domain is all real numbers, and our composed function is also all real numbers. My final domain is all real numbers, or negative infinity to positive infinity. Okay, so in number 4, we are going to look at each of these functions. So in letter A, we have a rational function. So with the rational function, the restriction that I have for the domain is that the denominator cannot equal 0, because you know that you cannot divide by 0. So that means for my domain, I have all possibilities of x's. I just cannot have the x value of -1. So again, if it's going to help you to make a number line, right, and you can see, oh, I can have everything except for -1, that might help you to be able to write your domain. So that domain is going to be, again, here, I'm going from -infinity, approaching that -1. Can't include it because it can't be -1. I'm putting that U or union, and then going from -1 all the way towards positive infinity. In letter B, you have a radical function. So the domain of a radical function is that whatever is under your radical, so which is also called the radicand, has to be greater than or equal to 0. So you cannot have a negative under a radical. So when we're looking at 2x minus 1 has to be greater than or equal to 0, I would add 1 to both sides, and I would divide by 2. So x has to be greater than or equal to 1/2. So I've got to have 1/2 going all the way towards positive infinity. In letter C, this is a linear function, and with a linear function, you do not have any restrictions. So this domain is all real numbers. So I'm going from -infinity to positive infinity. Okay, in letter D, we are doing again a composition. So you want to look at what is the domain of your inside function, as well as the domain of the composed function before you give the final domain. So let's go ahead and do the composition first. So h has to go into your g function. So you have, here is your g function. And in the place of x, you're going to plug in your h function. So 2x plus 3, and then let's finish off -1. All right, so you do have 4x plus 6 minus 1, which is going to get you 4x plus 5. So you do have a radical, so you know that you have to have whatever your radicand is greater than or equal to 0. So I'm going to subtract 5 and divide by 4. So there is your domain for your composed function. So the domain of the inside function, which was your h function, was again that linear. So that one is again all real, so we're good there. When you have two different domains, you do have to combine them when you're doing composition to give your final answer for the domain. So we have x has to be greater than or equal to -5/4. So that's -5/4, and then positive infinity. Okay, in letter E, again, a composition. Our h function has to go and be substituted into the f function. So we have our f function, which is a rational. We have h has to go, so 2x plus 3. And then you have the -3, and then you have 2x plus 3, and then you have a +1. So we are going to go ahead and combine that. So that's just 2x in the numerator, and then 2x plus 4 in the denominator. So again, in your rational function, you know that your denominator cannot equal 0. So we've got 2x... let's see, cannot be -4. So x cannot be -2. Okay. So again, there's your domain of your composed function. Your inside function was, again, your linear function. So that's all real numbers. So I know that x cannot be -2. So when I look at that, I'm saying, again, if you need to draw a number line, you can. X can be everything, cannot be -2, it can be everything to the right. So that would be -infinity, comma, -2, u, and then negative 2 to infinity. Okay, in question number 5, we're going to describe all the transformations. So here you see your parent function, right? And there is your transformed function. So the very first transformation you have is that negative. So the negative is that vertical reflection over the x-axis. The second transformation you see is that 2 that is in the front. So that is a vertical stretch by 2. The next thing you see is that minus 4 that is underneath the radical. So that is a horizontal shift going to the right 4. So remember that the inside is opposite. And then at the very end, you have the plus 7. So that would again be a vertical shift going up 7. All right, so in question number 6, we're asking you to graph. We are giving you the parent function, and then we've got some transformations that are happening right here in that equation. So let's look at the transformations first. That 2 is that vertical stretch by 2. The negative that is underneath the radical, that would be your horizontal reflection, and that would be over the y-axis. And then you have that minus 3 that's on the outside, and that is your horizontal shift down 3. Now it's important to understand these transformations and what exactly they are changing. So the vertical stretch is going to change your y's. The horizontal reflection is going to change your x's, and then going down 3 is going to change your y's. So we're going to start off by making a table to sort of help you to keep everything in order. So you do have a square root of x function. So your sort of parent function and those points from there is 0, 0, 1, 1, 4, 2, and 9, 3. Now, what you want to think about is, okay, well then how can I write these transformations and what x or y am I changing? So with the horizontal reflection, that affects your x's. So what I'm doing is I'm taking all my x's and I'm multiplying them by -1, or I'm really flipping all the signs. And in the y's, I am going to do a vertical stretch by 2. So I'm going to multiply my y's by 2, and then I'm going to subtract 3. So now we're going to go ahead and make our new table of values here. So changing all the signs, or multiplying by -1 would get me 0, -1, -4, -9, and then multiplying by 2 and then subtracting 3. So that would get me -3, that would get me -1, that would get me 1, that would get me 3. So there are your new points. So let's go ahead and plot those. -1, 1. We got -4 and then a +1. You have a -9 and 3. So making the table of values might actually just help you keep everything in order. So that way it makes it easier for you to graph those transformations. All right, so in question number 7, we are evaluating. So these are your x values. So when f of x, so when x is 6, so see which part of that domain it fits. So you have 6 is going to fit right here. So once you know that 6 is greater than 2, I'm going to take my piece of that function, so -2, and then I'm going to substitute that 6 in for x. So that gets me -12 plus 3, which gets me a -9. If I look at f of -3, so I'm looking to see where -3 would fit. It actually fit right here because I got the little line under there that is equal to. So I'm going to take, let's see, -3 plus 1. and then square it. So that's going to get me negative 2 squared, which will be 4. In C, we've got f of 2. So f of 2, exactly 2, would get me 5. And f of negative 10. So f of negative 10 is less than negative 3. So I'm going to fit right here. So I'm going to get negative 10 plus 2, which would get me negative 8. All right, guys, I hope you found this video helpful. Don't forget to like and subscribe for future notifications on other pre-calc videos. Thanks for watching and have a great day.